Hi, this is David Rehagen, and we're going to take a look at the DynamoDB extension from ThinkGeo. This is a technology preview, and what we're going to do is we're going to talk about DynamoDB from Amazon. We're going to review a sample application, and I can show you how you can possibly leverage DynamoDB for your spatial systems. The first thing to point out is that the software from ThinkGeo and the service, Amazon's DynamoDB, are both in beta. So just keep that in mind. As we move forward, this is all subject to change. What we wanted to do is we wanted to provide a compelling alternative to the normal spatial databases that are out there using DynamoDB. And what we're going to show you is how you can import your data into DynamoDB, consume it directly from the web, so your clients can consume it right from Amazon directly. And to do that, we've created a new layer and a new feature source. And we've also exposed the complete set of spatial functions that you're normally used to seeing with pretty much every feature source in our system. We've also implemented some client-side caching with expiration so that you don't have to always get the data from the server. You can cache it locally, but with the expiration you can control how old the data gets and how often you want it refreshed. So for those that are not really familiar with what DynamoDB is, it's a cloud-based NoSQL database. So NoSQL means that you're not going to do a select star from, you're not going to have very complicated where clauses, joins, group bys, those kind of things. But the trade-off is that by paring down the number of operations that you can do, it allows you to scale up and to do a whole bunch of things that traditional SQL databases have a hard time doing. And from Amazon's, a lot of these are directly from Amazon's website, is that they wanted to provide a fast and predictable performance. And I think that goes a lot with the NoSQL aspect of it. And they also wanted seamless scalability, and that's really big. So they wanted kind of you turn the dial to get more performance. It's not adding extra machines to a cluster, or you don't have to re-architect things. It's just seamlessly scalable. They also wanted to make it fully managed. So there's very little administration. And there's also no hardware to set up. You don't have to be a master at replication. You don't have to go down for software patching. You don't have to change topologies if you decide to scale up or deal with clustering. All that stuff's handled for you. And an interesting point is that the backend storage is all SSD drives. So they're pretty serious about getting the maximum speed out of things. And you can find more information of what DynamoDB is at their website. They talk about units a lot, and so 1 unit is roughly 1K. Of course, go and check this out for yourself. This is kind of just a snapshot of it. And then you pay based on the main part of the bill really is based on the allocation of capacity. So you pay 1 cent per hour for every 10 units of write capacity a second. So you're paying for 10K a second kind of bandwidth to write to the database. And then you pay a cent for every hour for every 50 units of, that's supposed to be read capacity there instead of write capacity. Sorry for that. So that it's much cheaper to read than it is to write to the database. And then also there's a storage fee of $1 per gigabyte of data after 100 megabytes per free a month. And so really the bulk of it is in that capacity. But the nice thing is that you can keep that low while you're prototyping and designing things, and then as you need capacity, you can literally just go in and type in a new number, and the backend will scale to provide that kind of capacity. The data transfer is free. Transferring data in and transferring data out, it's really cheap. Up to 10 terabytes is 12 cents a gig after 1 gig free. So you can also find their pricing online too. Of course, it's beta software, so hard to say what that pricing's what it's gonna do. But Amazon, it just all tends to get cheaper over time. So what is DynamoDB? with the Map Suite software, what does it have compared to existing spatial databases? Well, I think the first thing is low upfront costs. I mean, you can do all of this stuff in the web. There's no software licenses to buy. There's no hardware to buy. You don't really need any specialized knowledge to scale your solution. It's very simple to set up. Once you get your solution in place, there's no scheduled downtime or for patches. So with a lot of other spatial servers, you have to go down to patch it, and so if you want to be 24/7, it kind of forces you into a cluster situation, and there's a lot of expertise in that. Minimal administration. We're going to show you the front end. It's pretty simple. You can really almost instantly adjust your capacity, and the nice thing is that you're paying for capacity. So if you don't need very much capacity, you don't have to pay that much, and when you do need to, it's just as easy as almost turning a dial. You can do live backups to the cloud. I mean, your data is already in the cloud, so it's relatively easy to back that data up and to move it off into other places. And if your stuff is already deployed in Amazon, let's say in EC2, then as long as you're in the same data center, you get local speeds to that data, and so that can be a big advantage. So there's lots of things that make DynamoDB really interesting compared to a lot of spatial servers. Okay, the first thing I want to show you is under the Amazon Web Services Management Console. I went ahead and went to the DynamoDB section, and right now there's no tables, and so it's kind of a getting started screen here. And what we're going to do is we're going to run the demo. Actually, before we run that, it's important that you go into the app config here and you put in your Amazon username and secret key in there, so that it'll know how to connect to you and validate your account, etc. Let's go ahead and run this. And so what we're going to do to start with is we're going to import a shapefile into DynamoDB. So we're going to do a relatively small one here. Let's see, major cities. And it's just a little warning that we have saying that you're about to import 23 features. It may take some time to upload. And I put an estimate of about 20 features a second. It's going to take 1 second to do it. Also, we write a lot of information out to the output window via the trace, and so you can see kind of the status, because some of the operations are kind of slow to like create tables and to do different things. And so the output window is really the place to see what's really going on with it. And then also warning you a little bit to say, we start the tables with 50 units of write and 50 units of read. You can modify that in the sample, and I'll show you where to do that. But you may incur charges at this point. So we're going to go ahead and say yes. So down here you can see that we're going to be creating a table. We're looking for the table status. And if we switch back to here and refresh this, then now we're creating this layer catalog table. And there's an API that allows you to pick what name the layer catalog is. And it's creating this now. And it issues the command to create the table, and then we kind of poll to see when the table's done creating. And for this particular table, we have a default of 5 and 5 for the read and write, because it's really only on connecting to the table that the first time that you need to read the layer catalog. And now it's creating the sample layers. Sample layers is the table that we're actually going to store our information in. So as you'll see with the API of importing the shape files, you can specify a separate table for every shapefile, or you can put multiple shapefiles into one table. So if you put them into one table, you can specify what the layer name is, and it'll happily store as many shapefiles as you want in one table. That has the advantage of, remember, you're being charged by the read throughput and the write throughput. So the more data that you have in the table, and the fewer tables that you have, the better off you are on charges. Now, what's nice about putting each shapefile or a group of shapefiles in separate tables is that when you want to delete it, you can just simply delete the table I mean, when you call the delete on the API, it'll actually delete the table if it sees that that's the only layer in the table. And the reason why that's kind of important is that if you want to delete, let's say, 1,000,000 records out of a table, you have to issue a whole bunch of commands to delete those one by one if you have them in the same table. Alright, so it looks like it's done. So here we can load the layers. Right, actually it already loaded them. So we can click on this, we can toggle its visibility, and you can see down here that we're doing some queries and the capacity units that those are actually reading. And so here it brought those up. Now we've cached it, so if you zoom in now, you'll see that it took very little time. It didn't actually even go out to the web at all. And you can see that cache here. We can say open cache folder, and let's actually delete that one. That was from another area. And so there's the cache for that data. So let's go ahead and load another table in. We're going to load the US states. And now since the tables have already been created, it's going to be much faster to load that stuff in. Even though the data itself is a little bit bigger, there's a lot more points. And that's one thing that part of the technology preview is that we haven't really optimized the import process, because ideally you would want an import process where you could run it from multiple machines or multiple sources, since it's all kind of asynchronous up there on the web. So let's see if we say US states and toggle those. Here it's pulling that information down. And there we go. Now there's a spatial index that's utilized. So imagine that we were to import 100 million rows, 100 million features of road data, and you were at an extent where you just saw 100 roads. That data would come down nearly instantly, even though it's pulling from a backstore of millions of features. Alright, so we had a little problem. I had to reload that again. And what the system does is that when it loads the files, it just creates just a random color for the items that get loaded. We also have APIs in here to delete layers. So if we wanted to delete the major cities, turn that off, hit delete, and it would delete that. And so what it's doing there is it's deleting it from the catalog, and it's also deleting the data itself. And then we can also delete the cache. So let's see, if we zoom in and zoom out, you notice nothing's really happening here. And we can go ahead and delete the cache. Just saying that we're going to delete it. And when we zoom in or zoom out now, I'm sorry, we didn't select that. Select it and delete the cache. There we go. We go ahead and zoom in. Now it needs to go out and fetch that data again. And if we zoom out, it's going to reuse the cache, and there's more features that need to be pulled in. It's going to execute the query again. So let's take a look at what the API itself looks like. And here's the sample. So the first part of this is pretty mundane. It's just grabbing the access key and the secret key from the app settings, and then saying, well, if it's not there, then you need to add it there. Then it creates this security token. This is you basically use the secret and the access key to create this token that you send with all your requests. If you were to click the import button, a lot of this code is really just setting up the dialog and things like that. Here we're just looping through the layers to try to get the layer count so that I can create the message box that says how many features you're importing. But if we actually look at the line of code to export, it's really this line right here. We're also building the index if it doesn't have an index built for it. But this is the main line of code. And here you specify what the layer catalog table is. You also specify the table name here. So if we imported 10 files and they all had the same table name, all that data is going to coexist in there. Or you could specify different table names here. The next parameter is actually the layer name. So you could have the same table with different layer names. The actual shapefile itself, the path and file name to it. And then this is the feature density. It's for creating the index. Right now we have it defaulting at 4. If you had something like all the roads in Texas, you might want to use 6, but I would keep it between maybe 3 and 6. And then here, this is the columns that you want to pull in. This actually should probably be blank. We didn't pull any columns, but you can specify columns from the shapefile to pull in. And then we set the read and write capacity here to 50. So you can set that to whatever you want. If you want higher, read throughput, you can change this. But you can also change this after the table's been created by going into the UI. I can show you that real quick. So we can come in here, and if we wanted to change this, we could say modify throughput. And it only allows you to modify them by a doubling, but as soon as you double it, you can just come back in here and double it again. The one thing that's pretty important to note is that you can delete, I think, as many tables as you want in a day, or maybe there's some really high limit, but you can only downgrade capacity, I think, on a table once per, or 2 or 3 times per 24 hours. So you have to really watch out. If you increase this capacity a lot, you can't just decrease it whenever you want. So there's some limits on that. Check their documentation. And then you can specify whether or not you wanted to overwrite the data if the layer is already there, or if you wanted to kind of continue, and then you pass in that client, which is the kind of the Amazon token. So really, it's kind of a one line to get a shapefile from your local machine to Amazon's cloud. Now, if you wanted to delete it out, there's basically all this code is really to set up a dialog. The real API is on the DynamoDB feature source delete layer. You specify the catalog, you specify the layer name, and the client. So it's kind of one API to delete a layer. And then if by deleting, when it looks into the catalog, if it finds that the only layer in a particular table, or it's the only layer in that table, then it'll just delete the table itself, saving you time from executing individual delete statements. To load the layer list, it's pretty easy. We have a static function here, DynamoDB feature source.get layers and catalog. You specify the catalog and the client. It gives you back a list of all the layers with a bunch of information about those particular layers up there. So that's easy to do. When you actually want to, this is the code that we use to just load the layer on the map so you can see it. So what we do is we create a DynamoDB feature layer. We give it a layer name. This is the layer name that you have it stored up on the server. We give it the layer catalog table name, and then we give it the client. Then here we're just setting some, if it's a line style, we just create a simple line style with a random color. Same thing with point area. We open it, we add it to our layers to draw, and that's basically it. So the layer works just like any other layer in MapSuite. It's really easy to use. You can say DynamoDB feature layer dot query tools. You can do get features nearest to. You can do unions and all kinds of stuff like that. So that's all supported. Currently, right now, editing isn't supported, but that's something that we're going to be working on. There's a lot of interest to it. Let's see, opening the cache folder, we have a static method here on the DynamoDB feature source to get the default cache folder. Of course, on the layer, you could specify your own cache folder, so you can control where that goes. And to delete the cache, we have another static method right down here. Actually, it's not static. We create the DynamoDB feature layer, we open it, and then there's a delete cache method that'll delete the cache as well. Or you can do it manually. You can get whatever the default folder is. The subfolder would be the layer name, and you can just delete the cache that way as well. and the rest is just some things to do the drawing. And if you noticed in the sample, we're using the map suite core to do all the drawing, so we wanted to do that so there wasn't a dependency in this, just in the sample for the desktop or WPF or web. But it makes it to where there's a little bit of extra code that we have to put in there because we have to use the GDI plus GeoCanvas directly to do the drawing. But as you can see, it's really easy to import your data in there. Lots of clients could connect from all over the world to download the data, and it's very easy to scale this up. And what we're really looking to do is to potentially expand this technology preview to create a full-fledged extension with editing, with better caching, with higher speed, importing, with all kinds of features. But we really want to get feedback from you guys to see if this is a technology you guys are interested in, if this is something you want to integrate into your applications, and really just kind of go where the need is. So we wanted to introduce this to you to kind of see what you guys thought of it. So if you have any questions, take a look at the news and announcements area in our forums, and there should be under the announcement, you can go ahead and post questions or and get in contact with us. All right, thanks. Bye-bye.